Hi guys, in this particular video we will learn some complex numerical which is based on CSCE, that is input stage is JFET and output stage is CE, multistage amplifier. Here we have to directly deal with particular numerical which is asked in your one of the Mumbai University question paper for May 2018, right? So in this particular question, something is different been asked than rather than that of your conventional questions. So look at this particular question and we'll try to solve it. So here in this particular question, we have to solve the complete AC and DC analysis, and they ask us to find the value of RS, right? So that is the different question, RS, Q point for each stage, and we have to draw the AC equivalent model and find out the value of voltage gain. So only voltage gain is been asked, whereas the given values are VGS is equal to -1 volt, IDSS is given as 8 milliampere, VP which is given as -4 volts, HIE which is given as 1 kilo ohm, HFE which is given as 100, VBE which is given as 0.6 volts for BJT, right? So for JFET and BJT, all the specified rated values are given, and just we'll have to move further to have the analysis. This question is been asked for 8 marks in your May 2018 question paper for Mumbai University semester number 4. So let's see how to calculate the first finding. So let us have step number 1. We'll have to say that we'll have to first move for DC analysis. So as far as DC analysis is concerned, do we really require DC analysis calculation? Yes. As far as JFET is concerned, we don't know the value of GM. As far as BJT is concerned, we don't know the value of RPi and your value of GM for that particular BJT. Okay, so the GM1, GM2 value we have to find out, as well as we have to find out the value of RPi, and moreover we have to find out the value of RS, which is been asked in your exam question. Okay, so first of all we'll directly turn into your given values. From the given values we'll try to find out what will be the value of RS. Okay, as far as the DC analysis is concerned, we'll draw first the DC equivalent circuit by opening all the coupling capacitors and bypass capacitors. So here we will open all the coupling capacitors and bypass capacitors, so that we will be getting the JFET first. Now here two stages are independent to each other but not identical, so mind well. Okay, so as far as the stage 1 is concerned, we'll note this as stage number 1. Okay, and then further we'll try to find out the parameters for stage number 2 also. As we know that, what is the value of VGS? VGS is given as -1 volts. Okay, and we all know that what is the value of VGS? Apply KVL at the input side. So apply KVL at input loop. Here we don't require to have the Thevenin's equivalent circuit as it is of a simple self-biased circuit. So I can say that the input stage, if I give the KVL, then I'll get to know that the value of VGS is equal to minus of ID into RS. Okay, but I don't know the value of ID. So first of all, we have to calculate the value of ID from the formula itself. We'll get to know that IDSS multiplied by 1 minus VGS divided by VP the whole square. So this Shockley equation will be getting the value of IDSS, which is given as 8 milliampere, 1 minus VGS which is given as -1, VP which is given as -4. So from that we'll get to know that what will be the value of ID, right? So we'll be getting the value as 4.5. So 4.5 milliampere, that is the value of ID, right? And that value of ID, I'll put it over here in this particular equation, so that we'll get to know that what will be the value of RS. Yes, we have got the first finding here. Yes, RS is equal to VGS minus VGS divided by the value of ID. VGS is equal to 1. Minus of -1 will become +1. So divide by ID is equal to 4.5 milli. Okay, so we'll say that this 4.5 ka inverse, that will be 0.222 kilo. So here we'll get the value of RS. We have to decide the value of RS. RS is equal to 222 ohm. Right? We have to take at the lower side. If we want to design the value of RS, then we'll have to say that its standard value of RS will become 220 ohm. Okay, with 0.25 watt power rating. Okay, so all these values of RS with standard calculation, standard resistance is available in the market. So we'll take this as your first finding. So we have got the first finding, but not yet have got the values which are required for the AC analysis. That is nothing but GM1. So simply we'll calculate the value of GM1. So value of GM1 is nothing but GM1, I can say, that is nothing but GMO into 1 minus VGS divided by VP, not whole square. It's just a bracket. So we'll have to calculate first what's the value of GMO. GMO is nothing but 2 into IDSS divided by mod of VP, and that comes out to be 2 into IDSS, which is given as, I guess, 8 milliampere, and VP, which is given as 4. So GMO will be getting as 4 millimho, right? So GMO is 4 millimho, and VGS value is already given -1, and VP value is already given, that is of 4 volts. So 1 divided by 4, that is 0.25, 1 minus 0.25, that is 0.75, multiplied by 4. So you will be getting the value of GM1 after putting the values of GMO over here and putting the value of VGS is equal to -1 volts and VP is equal to -4 volts. We'll be getting the value of GM as 3 millimho, right? So here we have got the first parameter which are required for the gain of the with AC analysis, right, for the first stage. So let's move to the stage number 1. So let's move to the stage number 2, right? So as far as stage number 2 is concerned, we'll again draw the DC equivalent circuit with opening all the capacitors. So this is your simplified circuit. Here we have to have the Thevenin's equivalent circuit. So as far as circuit is concerned, we will just note that $56 kilo, then the values of 10 kilo, here 2 kilo and 500. Okay, so as far as stage 1 is concerned, we have finished, not yet got the values of Q point. We'll calculate it later on. First we will find out the value of which is required for the AC analysis. We'll find out the Q point of stage number 2, and then we'll move towards the stage number 1, the Q point analysis. So this is your plus 15 volts. Have to calculate the value of VTH and RTH, right? So we'll have to say that RTH is equal to 56K in parallel with 10K. Calculate the value, come to me. Then VTH is equal to, can say that 10K divided by 56K plus 10K multiplied by total voltage, that is 15 volts. Calculate the values and come to me, and then we'll form the AC Thevenin's equivalent circuit. So we have got the values of RTH and VTH as 8.485 kilo ohm, yes, and VTH is 2.27. Got these values. Let's move ahead to find out to draw the Thevenin's equivalent circuit, and then we'll move towards the finding of the Q parameters. So here my Thevenin's equivalent circuit is Thevenin's equivalent circuit. Let's draw a simple circuit where BJT, resistance, and this RTH, your VTH, and then ground. This is your input KVL. This is your value of RC and this is your value of RE. Okay, this having 15 volts. Just have to look at the input side. We'll have to apply input KVL. Here we'll say that this is input and this is your output. So apply KVL at the input side. We'll say apply KVL at input side. So whatever KVL formula we'll be getting, from that we'll get the value of IB. I'll directly write the value of IB as VTH minus VBE divided by RB plus RB is nothing but RTH. I can say, I'll say that this value is RTH plus 1 plus beta is nothing but HFE multiplied by RE. Okay, so put the values of RE, RTH, HFE is equal to 100, VBE is equal to 0.6, not 0.7 because 0.6 is given. VTH we have got 2.727 something, and get the value of IB, 28.35. So IB you will be getting 28.35 microampere, right? And obviously whatever value you have got, you have to calculate the value of Q parameters. So we have to say that this is IBQ, and from that you will be getting the ICQ as 28.35 multiplied by beta, that is nothing but the HFE. So multiplied by HFE, which is 100. So here we will say that the value is nothing but 2.835 milliampere. And from that value we will apply KVL at the output stage. So simply we will first apply KVL at output. So if you apply KVL at the output, you will be getting the equation as VCEQ, which is equal to VCC minus IC into RC plus RE, right? Here I am considering the fact that as HFE is equal to 100, which is high, right? So I am considering the fact that IE, which is nearly equal to IC only, right? So that's why we have got this particular formula, VCC minus IC into RC plus RE. Okay, what's the value of RC we have got? RC is equal to 2 kilo ohm. So 2 kilo ohm plus 500 ohm multiplied by IC, and that we have to subtract it by VCC. Okay, so just do this calculation. VCC is equal to 15 volts. Whatever value you have got, that is 7.912 volts. So ultimately for stage number 2, we have got Q2, that is nothing but VCEQ, comma ICQ, that is equal to 7.912 volts, comma 2.835 milliampere. So this is the second finding, or I can say that part of second finding that we'll be getting. I'll say that equation number 2a. Okay, now we'll again have to move further for the required parameter for AC analysis as far as stage 2 is concerned. Okay, so for stage 2 we require the value of GM2. That GM2 is nothing but 1 upon RE2, right? And we all know that what is the value of RE2? The value of RE2 is equal to VT divided by IE. As we have said that IE is nearly equal to IC, so we have to incorporate that IC into this particular formula. So RE is equal to 26 millivolts. That's a value, concrete value of VT we have considered, and IC is equal to 2.835 milliampere, right? And we'll get the value of RE. From the inverse of RE, we'll get the value of GM2. So this RE2, 9.17 ohm, that is the value of RE2, and we'll get the value of GM2 is equal to RE1 ka in RE2 ka inverse, that is nothing but 0.109, right? And that is nothing but the required parameter for the AC analysis, right? So this is important for AC analysis. Moreover, we require the value of RPi2, right? So RPi2 is nothing but, which is given as HIE. So it's nothing but the value of HIE we have to consider, and this is nothing but from the given parameter, that is 1 kilo ohm. 1 kilo ohm, right? So as far as HIE is concerned, if HIE, HFE values are given, then I can say that we have to include the H parameter AC equivalent model, and then we'll calculate from the H parameter AC equivalent model only. Let's move further for the next AC equivalent circuit. Before that, we have to calculate the Q parameters. Okay, so we have to calculate the Q parameter for the first stage. So we'll say that Q point for stage 1. So as far as Q point for stage 1 is concerned, we just have to go for the output KVL. That's it. So as we have know that this is your RD, this is your JFET, and this is the calculated value of RS in the first step. Here it is 15 volts RD, RS, and it is connected to ground. Already we have know that the value of ID, we have got the value of ID as 4.5 milliampere, and we have got the value of RS as 220 ohm, right? And moreover, we have also got the value of VGS is equal to -1 volts. So that is one of the Q point I can say. So IDQ is equal to 4.5 milliampere, VGSQ is equal to -1 volts. We have to find out the VDSQ. So this is nothing but the VDSQ. So I can say apply KVL at output of stage 1. Okay. So once we go for the output of stage 1 ka calculation KVL, we'll get to know that VDS is equal to VDD, that is nothing but 15, common for stage 1, stage 2, minus ID into RD plus RS. So let's see that this is 15 minus ID value is 4.5 milli, and RD value is given as 2 kilo ohm. So here we can say that 2 kilo plus 220 ohm, and we'll have to calculate the value of VDS. Calculate this value. VDS becomes 5.01 volts. So second Q parameter we have got, that is nothing but Q point for stage 1, that is nothing but VDSQ comma IDQ, that is 5.01 volts comma IDQ is 4.5 milliampere. So this is another second part of your second finding. Let's move towards the third finding, where we have to move further for the step number 2, that is nothing but the AC analysis. So up till now we have done is only of the form of DC analysis. Now within a minute, try to draw AC equivalent model for CSCE multistage amplifier, right? And then come to me. Here now, in the step number 2, we have to deal with the voltage gain. That is the another finding asked in this numerical. So as far as AC analysis is concerned, we already have formed the AC equivalent model that comprises of stage number 1 and stage number 2. Stage number 1 consists of JFET and stage number 2 consists of BJT. So in BJT, if you note that this is the problem, and here we have 500 ohm which is not yet bypassed. So I can say that 500 ohm I have to show the AC analysis in AC equivalent network. So I can say that this is RE1 will be come into picture, and here it is bypassed, so there will not be any source resistance. RG1 will be there, everything will be there. So what we'll have to do, this is your output voltage, we'll have to find out the voltage gain. Simple. All the parameters required for the voltage gain R we already have calculated. That is nothing but the GM1. What is the GM1? GM1 we already have found out as 3 millimho. Then HIE which is already given, HFE which is already given, and here is RC2 which is already given. Okay, so what we'll have to do, we'll have to calculate directly the voltage gain. So voltage gain, this voltage gain is nothing but, let's say, AV. Okay, I can say that this AV is equal to VO divided by VI is equal to, here I can say that it's a VO1. So VO divided by VO1 multiplied by VO1 divided by VI, and that is nothing but AV2 multiplied by AV1. Okay, so as far as AV2 and AV1 is concerned, we just have to know that we have to consider only the single stage BJT and single stage JFET amplifier ka voltage gain. So that formula we will use, and we'll get to know that what will be the product of AV2 and AV1, that will be your total voltage gain. So let's see the calculation of AV2, right? So AV2 is nothing but, we will be getting the value of AV2 as, see to it that this RE1 is coming into picture, right? So your gain will reduced by factor HIE divided by 1 plus HFE into RE1. Okay, so that will be obviously done by taking the KCL at this output node. So we'll be getting the direct formula, as we can say that this will be your HFE into RC2 divided by HIE plus 1 plus beta times, or I can say 1 plus HFE times RE1. So here I'll write the formula in terms of H parameters. So this is nothing but HFE into RC2 divided by HIE plus 1 plus HFE into your RE1. Okay, so just have to calculate this all factors, and then we'll have to get the value of AV2. So just calculate these values, obviously with minus sign here we'll be getting, and calculate these values just by putting the values of HI, HFE, RC2 and RE1, and then come to me. This is the a simple formula, and from that we have got the value 3.88. Okay, this is the formula with which we'll get the value of AV2 and then move the value with AV1. Let's calculate the value of AV1. AV1 is nothing but the voltage gain for first stage. So VO1 divided by PI I have to find out using JFET. So we'll have to apply the formula for JFET with bypass capacitor, and we will say that this obviously this is your RD1 here I can say, and RD1 and RB2 are in parallel, and we will say that this AV1 will become minus of GM1 into directly RD1 in parallel with RB2, right? Calculate this value and then come to me immediately. So answer is 4.855 minus 4.855 is the value of AV1. Now we'll have to do the voltage gain. Voltage gain AV is equal to AV1 into AV2, and that comes out to be from 4.855, we'll say 4.855 multiplied by minus 3.88. Okay, so obviously both having minus sign, minus minus will get cancelled, and we'll be getting 18.84 is the total gain that I'm expecting from this particular circuit. So total gain is 18.84. So that is the last finding that is expected from this particular numerical. Okay, so as far as this is the fourth equation, and obviously they ask us the third finding is nothing but the AC equivalent network. So this is the AC equivalent network. So the answer for this complete numerical I will summarize in the format as, let's say RS we have got the value as 222 ohm. Obviously we have already written it in standard formula as well, RS. Then Q parameter we have got Q parameter, let's say Q1, that is for first stage. Q parameter we have already got, and that is nothing but 5.01 volts, 4.05 milliampere. Obviously, this Q1 gives the value for VDS and IDQ, right? Q2 will be getting, that is 7.912 volts, 2.835 milliampere, and that is nothing but VCE, ICQ. And the last one we have got as a finding, AV is equal to 18.84. So this is nothing but the answer which is expected from this particular numerical for 8 to 10 marks. So just learn from this particular numerical, and we will learn few more videos which is consisting of complex numericals and more complex circuit of multi-stage amplifier. So stay tuned for that. Learn more and more ADC2 with me with Ekeeda videos. Subscribe the channel of Ekeeda videos. Thank you so much.